we have lots of bats in North Carolina, so I'm not going to just list, we have this bat and we have this bat, because that would take way too long. But if you have a specific question, just let me know. All right, so they are the only true flying mammal, and about a quarter of all mammals are bats, which is kind of cool to think about. We just don't think about that, but it's pretty neat. They're on every continent except Antarctica, and they are very long-lived, 30, 40 years, just depending on, and that's in the wild. So we tend to think about, you know, something can live 40 years if it's in captivity and being taken care of, but some bats they have found have lived up to 30 or 40 years in the wild, which is pretty amazing. So we call them megachiropterans and microchiropterans. You might also just hear megabats and microbats. And basically the megabats are bigger bats, and those are the fruit-eating and nectar-eating bats. And then the microbats are the smaller bats. Those are the bats that we have here in North Carolina and in the United States. And so there are about 166 species of the megabats and almost, 760 species of microbats. We have 17 in North Carolina, 47 in the United States. So 47 species in all of the United States, and 17 of those get to be in North Carolina is pretty cool. It's always nice. We have lots of diversity in North Carolina, so bats are no exception. And chiroptera just means hand wing. I'm going to show you a skeletal picture in a second, but you'll literally be able to see they just have elongated fingers with skin over them, and that's how they fly. So a couple of differences between mega and microbats, just to kind of get you thinking about diversity in bats, because it is amazing the diversity in the bat world. Megabats are eating fruit and nectar, right? They're looking for that food. So echolocation may be something that you've heard about that bats do. Megabats don't do that because they don't need to. They're flying around during the day because they're looking for fruit and they need to be able to see it. And it's a very visual thing, scent thing too, but they don't need to echolocate it because it's not moving, and they don't need to find it at night. So they have big eyes to be able to see, but they have small ears because echolocation is a sound thing, and so they don't need to have big ears like the microbats. So the microbats are flying around in the evening looking for insects. That's where echolocation is coming into play. And so ears are a bigger priority than eyes. They can see, but just like us, they don't have big enough eyes to see well at night like an owl, for example. So they've compensated. They've sort of chosen, if you want to think about it in that manner over time, that having smaller eyes is less important. Having bigger ears is more important. So instead of having both, they have bigger ears, and it helps them see, or kind of see their food, find their food in the evening. So the largest bat is almost 2 pounds, which is huge in the bat world, considering some of our bats are just weighing a few grams. And its wingspan is up to 6.5 feet. It's a flying fox, so it's a fruit eater. We don't have those here. The smallest bat weighs less than a penny. So that's a full-grown bat just across 2 fingers in his hand, about the size of a bumblebee. That's not a North Carolina bat, but it is a microbat, similar to the bats we have in North Carolina. Our bats tend to fall in, our biggest bat is about the length of your palm. Most of our bats are about halfway down your fingers to your palm, body-wise, length of their body. So if you want to think about how small bats are, if you haven't seen one before, they're typically fitting in the palm of your hand. And when they spread their wingspan fully out, it might be a foot or less, just to kind of give you some idea of where our bats fall in that. So this is why they're called hand wing. They have 5 fingers, just like we do, and their fingers are elongated, and then there's skin on either side of those fingers, and that's what lets them flap around. And the cool thing about that is, if you think about taking your hand, you can maneuver it all over the place. So bats can fly with just crazy amounts of maneuverability, unlike a bird, because it's just a hand. So that gives them a lot of flexibility. And if you think about the fact that they're trying to catch insects and moths and things that are small like that, typically speaking, well, you would want to have maneuverability, right? Because you need to fly after things that are tiny like that. So it works perfect. So just a few kind of cool characteristics about bat anatomy, because I think they're pretty neat. There should be a pointer. Nope. Yep, probably somewhere that I don't know how to use it. But on the nose of a bat, they sometimes have what we call a nose leaf. And if you start Googling pictures of bats and just like diversity of bats or something, you'll see there's like bumps and nodules and folds and just kind of weird stuff all over their face. And in microbats, that's all related to echolocation. So if you're sending a sound out of your mouth or your nose, it's hitting something solid and bouncing back. It's just like inside of your nose, you have all these ridges to help you gather smells, right? It's the same thing on their face. It's all about getting that sound back and collecting it towards their ears. So nose leaves help send that sound out directly in front of them, and they just look really funny. Not all bats have them. But that's what we call them. Another really cool thing related to echolocation, and I think I have a better picture later on, is they have sort of a little inner ear and an outer ear. So their outer ear is real big, and then they have this skinny little thing sticking up inside that ear, and it's called a tragus. And that's the same thing. It's all about having all those ripples and bumps, which help funnel sound. So a couple cool things about bats having a nose leaf and having a tragus. And if you want to impress your friends with new vocabulary, did you know bats have nose leaves and they have a tragus? In case you're wondering. The other variation on bats that you wouldn't necessarily notice when they're flying around is not all bats have tail membranes, so there's a lot of variation here. So for some bats, there's no tail membrane, and so this skin is just not here between the legs. Some have a complete tail membrane, and they have a tail which serves as a rudder, kind of, and that tail can just stop at the end of the tail membrane. For others, like a Mexican free-tailed bat, that tail sticks beyond the tail membrane. So if you wanted to look at a bunch of different bat pictures, that is one thing you notice is different between different species of microbats, is whether they have that full tail membrane or not. And they use that a couple different ways. Sometimes the tail membrane, a female will give birth upright instead of the way they normally hang, upside down, and she'll use it as like a parachute, or what am I trying to say? Scoop, and the baby will deliver into the tail membrane, and then she'll kind of use it to hold the baby up and let it crawl up on her. They can also kind of catch insects that way with their wings and with their tail, and then scoop them into their mouth and eat while they're flying. So the tail membrane helps in flight, but it also can help with other things as well. They just don't all have the same shape. And if you're into terms, because you see it up here, cow car right there, there's just a kind of protrusion of a piece of bone that supports that tail membrane. It's just an edge that supports the tail membrane. All right, so I mentioned echolocation sends a sound out. And the way echolocation helps them find something is they can send those sounds out kind of slow, and they'll get information back, and it might say like, big wall, right? That's not interesting. Insect, car, right? And when they get information back that seems like something they're interested in, they will send out faster echolocation clicks, right? Sounds. And they get more information back more quickly, and they can hone in on that insect or moth or fly or moth or beetle or, whatever they're wanting to eat.
Natural instinct to know that, oh, that's a wall, I'm not interested, or did they learn it?
I would say it's instinct, because they are not with their moms but less than about 2 months, and that you don't see them, they're not flying together for her to like teach them. So yeah, I think something like, it's big, turn, you know what I mean? Like, I gotta get out of the way. Because when you see them flying through trees, They're not slamming into branches and, and trunks, and they can maneuver really well. I mean, and they can see, so they are also just using, something's in my way. But when it's real dark and there's not a lot of light, then just like us, they have a little bit harder time seeing. So echolocation is helping get a clearer picture than what they're visibly seeing with their eyes. So I mentioned this already. They are sending this sound out. It is coming from their voice box, but either through their nose or their mouth. And then when it hits something solid, it comes back. Typically, we're not hearing those sounds. There's lots of ways you can convert sound waves so we can hear them. And they do make audible noises that we can hear. But I don't know a lot about sound, so I'm not going to act like I do. But the frequencies are not where we can hear them when they're echolocating. But they can also make sounds we can hear. I should, if the sound works, be able to... Oh, we should turn it up. It's still low. Do we have a way to turn it up? We might not.
Let's see if it's on the, if we can get it up on the TV or not.
So each bat has their own particular sound, each species. There we go. That's converted to a sound wave we can hear, a frequency that we can hear. So that's a tricolored bat. And that's a big brown bat. And so again, that's not what it sounds like audibly, but they've converted it so we can hear it. But the point is that every species has their own sound when they are echolocating. The cool thing about that is we now have programs where all that information is entered. And then I'll tell you more about it at the end when we talk about citizen science opportunities. But we can run routes where we just drive. We have a microphone and collect all that information and put it in that system. And without having to physically see those bats and ID them, we know, hey, we had 10 tricolored bats and 20 little browns and, whatever. We can pretty closely. Some of them are not, you can't get exact with that program, but most of them you can get pretty close, which is a cool opportunity for us to get to identify bats without having to handle them. So bats eat a variety of foods. I mentioned all of our bats are insect eaters, but there are a lot who are fruit eaters. There are even a few who are meat eaters, and then there are 3 species of bats that are that drink blood, the vampire bats, and they're not stabbing anything in the neck. They typically are either specific to birds or specific to large mammals, mostly cows. They kind of follow herds. And they just make a scrape on the leg of the bird or the cow and lap up the blood and then, go away. And the animal doesn't even know they've been there. It's just a little bitty scrape. So it's not a thing.
How big are the vampire bats?
They're about the size of our microbats, so they're pretty small. The cool thing about vampire bats, well, there are lots of cool things about vampire bats, but one of the cool things is they walk well. So bats' knees are turned backwards because it makes more sense with hanging and how they need to take off, but backwards from us. But vampire bats' legs are a little bit longer and they function a little bit better. If you watch a bat try to crawl around on the ground, it's so clumsy. They can't do it well. But a vampire bat does, and that's because if they land on an animal, it's a little more noticeable. If they crawl up the leg of the animal, they tend not to notice them. So they might land a little ways away and then crawl up the cow's leg or the bird's leg to then make a scrape. So one of the cool things about vampire bats. So they typically mate in the fall, and lots of animals have ways of not getting pregnant right away because it's a good time to breed, but not a good time to be pregnant. So the way bats handle that, there are 2 ways bats handle that, and it's basically just delaying the growing of that egg. So they're either going to delay, they're going to let the egg get fertilized like it normally would, but then just stop growing until it makes more sense to be pregnant and then it starts growing again. Or many of them do what we call delay fertilization, which means the female has the ability to store the sperm, but it doesn't fertilize the egg yet. And then in early spring, when it's about to be a better time for her to be pregnant, the sperm will then fertilize the egg. And they typically only have one baby. Some have twins, but babies weigh almost half the mother's weight, 40% usually. That's like us giving birth to a 20 or 30 pound baby typically. Pretty traumatizing to think about. So one baby's plenty in most cases. Although some of our smallest bats have two, which is quite ironic, but. There is a baby of a big brown bat, which is one of our bigger bats. And you can see how tiny the babies are. But still, considering the bat, the bat's body is probably this big. And you can see the baby, fits across those fingers. So it's still a pretty large baby, even though it seems so tiny and adorable. That's cute. So this is a mom, and I was thinking there was another one, but maybe not. All these pretty furless, big-eared babies. These are Mexican free-tailed bats. Are hanging out in a nursery colony. And moms of some species, not all species do it, but some species will colonize together for different reasons. And one is to have a nursery colony. So all the moms and all the babies come together. And then they can take turns babysitting while the others go feed and then coming back and babysitting. But you're still nursing your own baby. So vampire bats will take orphans, but most other bat species don't typically take orphans. So they're still just feeding their own. They produce milk. They're a mammal, so they're nursing, but they're watching out, for the other ones. They're just not feeding the other ones. The other reason that bats might colonize in some cases is for hibernation, and then there are some bats who still hibernate solo. So it's all species specific. There's a lot of variation. But basically the purpose of an animal hibernating or going into any sort of torpor or kind of slow down period is a lack of resources, right? It can happen in the summertime, it can happen in the wintertime, pretty much any time of year. If a particular species doesn't have the resources they need, they have to choose to either migrate out of the area to find those resources or to hunker down and save energy until those resources are available again. That could be water, that could be food, etc. So for bats, there are some bat species who migrate pretty significant distances. It's not like birds where it's north-south, it's just elsewhere. So it can be west-east, the area they don't have insects anymore because it's getting too cold, for example, so they have to go somewhere else. It makes sense if they're in an area that's cold, they're probably going south because that's usually where it's going to be warmer, right? But it's not necessarily a directional thing, it's just we don't have what we need here anymore. Many of our bat species, though, hibernate, and they tend to use caves and mines to do that. Sometimes they use attics, cracks of bridges, pretty much anywhere where they can get out of the weather and get protected. So during hibernation, they are trying to conserve energy. And what do you think takes the most energy for a mammal? What is it about us that burns all of our energy? Body heat. So the way to conserve energy, cool your body down. So for mammals that are hibernating, in most cases, they are cooling their body temperature down pretty significantly because that's where you lose most of your calories. In a bat, they typically go down to 40 to 50 degrees. Most caves are in the 50-degree range. So it's perfect because a lot of them can fit in there. Like I said, some hibernate solo, so they're not using each other's body heat. They're just using the surrounding air temperature to maintain that temperature, not getting colder but not getting warmer. When you start to warm up, you burn calories, so they wouldn't want to be somewhere where the temperature fluctuated naturally in that space. So 100 degrees to about 40 or 50 degrees, and then their pulse and breathing everything slows down. So they go from somewhere between, really this is a huge range, but 200 to 1,000 beats a minute, because when they're flying, their heart rate is much, much faster. Sitting can be anywhere from 200 to 600 beats a minute, depending on the bat, to down just to 10 beats a minute. So, you know, just barely beating. And then breathing every few minutes. It's not much. And that's just keeping that heart pumping so it will function, and keeping those lungs moving so that they will function. But that's about it. You're shutting everything else down that you don't have to. But if a bat is hibernating like that, they can't do that all winter without waking up. So they will get up every once in a while. They have to burn a lot of energy to do it, but they will get up every once in a while and they'll go to the bathroom. They have to breathe off some of that carbon dioxide, because only breathing a couple of times a minute, you know, they basically need to hyperventilate a little bit to pull off that extra carbon dioxide. And so they'll wake up and do that. They'll go to the bathroom. If there's some insects out or something, they might eat a little bit, but basically they're just maintaining that, and then they're cooling back down. That's important to note when we talk about some of the threats to bats. It directly is affected by this ability to cool down. So if a bat is not using a cave or a mine that's staying around the 50-degree range, they might be in an attic, they might be in a crack of a bridge, they might be in even just behind bark on a tree, like if there's kind of loose bark, they can get behind that. Some even hibernate down in leaf litter. So pretty much anywhere. The ones you will see that tend not to use caves and mines, we've sort of started separating them, and we're calling them tree bats, meaning they're usually, if they're not in a cave or a mine, often they never use a cave or a mine. They're kind of picky. They either sometimes use it, and if that's the case, they're going to hibernate there, or they never ever use it, and they will use a tree in most cases. And so those tree bats are in a space that fluctuates a little bit more, which means it gets a little bit colder, and they tend to be more heavily furred than the bats who are using caves, because that temperature is more consistent. It makes sense that they would need a little bit more protection. So this is, I just think it's a cool word, Hibernacula, because Dracula, it just was like a cool name. I didn't make it up, but somebody did. And the place where a bat is going to hibernate is their Hibernacula. So it wouldn't have to be a cave, it could be somewhere else. But if bats are hibernating there, then you call that a Hibernacula. So this is a Hibernacula, a huge cave. Most of our caves in North Carolina are not this big and open. But this is an example of one where you have tons and tons and tons of bats. And they group by species sometimes. So even on the same big wall, you might have a certain type of bat here, and a certain type of bat here, and in this crevice over here is a different kind of bat, and in that hole over there is a different kind of bat, and there'll be lots of different bat species using one cave. It's kind of like multiple story apartments, right? And some people like being on the 5th floor, and some people want the basement, and there's all kinds of variation. If you've ever been to Linville Caverns, and you saw these tiny little bats hanging out on the wall, if you saw them, those are typically tricolored bats. They used to call them pipistrel bats, but then they had to change their name because somebody decided that that wasn't accurate enough. So they're tricolored bat because their fur is kind of tricolored. And they are very small and tough as knots. They only like to be by themselves and in the coldest part of the caves. And so they get condensation on them because it's gotten so cold and their body temperature is so cold. So I just think they're the coolest bats because they're just this tiny little pug nose, they look so dainty and tiny, and they're just so tough.
So that's icicle?
It's just condensation. Yeah, it's just wet. That's right. It kind of looks like icicles, but it's not solid. It's just, it's not frozen. Yep. But bats need to sleep when they're not hibernating, right? During the rest of the year, they need time to to rest and sleep during the day. So there are the Hibernacula roosts we talked about. There are also summertime roosts, springtime roosts, when they're just needing a place to rest. And that might be in a tree, that might be under a bridge, that might be the eaves of a house. You know, anywhere where they have a space where they're a little bit protected during the day. They're not in the, you know, like dead of the sunshine, you know, the bright sunshine. And they're not messed with, you know, so just somewhere where they can be a little bit protected. There are the nursery colonies that I mentioned. They very specifically go to one place to take care of all the babies. There are feeding roosts, meaning I might live over here, but there's a lot of really good insects over there, over that creek. And so I might go out in the early evening and I might fly around for a while, but I'm not going to fly around for 6 hours. So I might just go to a nearby tree and rest a little bit, and then I might come out and fly again before I come all the way back home. So the reason I mention those different places is because we tend to think about caves being important, or, you know, an abandoned mine or something like that being important, but we don't think about even just trees next to a lake or next to a river are really important. It blocks our view of the river, so we tend to just cut them down and want to put our house there because it's really pretty. But those trees serve a real important purpose for bats just on a nightly basis. Being able to have a place to come back and rest at for a few minutes is also really important. These are big brown bats. They kind of look, this is not a close enough picture to let you see it, but if you Google big brown bats, they kind of have dog-like faces. They have a little bit longer snout than some of the more smushed-faced bats. They are a little bit bigger bat, and they tend to like eaves of houses, and that's where this picture was taken. So one of the, how many of you have heard of Whitenose Syndrome? Okay, so this is huge, and it's a little depressing for a few slides, but then I have some positive slides. So you'll hear all this really terrible stuff for a couple of slides because I want you to know what it is, but then we have some good things happening, so I'll mention that. So Whitenose Syndrome, oh, there's the picture. It was named that way because they went into these caves and started noticing these bats had this like fuzz that was growing on their wings and their noses. And so they called it Whitenose Syndrome. We've now learned, we thought at first they were getting suffocated or something because it was all around their nose, but that's not the case. But it does tell us that it's on them when we see that. But it's a cold-loving fungus. Why would a cold-loving fungus be such a problem for bats? Hibernation, right? So during the summer, it's not really an issue. Bats are flying around, they clean themselves, you're getting rid of it. But in the wintertime, and on us, it's not a problem because we're 96 degrees, right? But on a bat who's 40 or 50 degrees and it's a cold-loving fungus, it can just go nuts in their body. And their metabolism and, you know, everything is slowed down, their immune system, so it can really wreak havoc on them during that time period. So in 2006-07, winter of 2006 and 7, biologists were out surveying a cave, and they came into the cave that they had been in before, seen lots of bats, and 99% of the bats were dead on the ground. And I mean, like from one winter to the next. And they didn't know what was happening. So that's where we consider the epicenter of where it started, although potentially it could have been somewhere else, but that's where we saw it first, up in New York. And since 2006, along the East Coast and now the central states, I'll show you a map here in a second, we're estimating around 7 million bats have died. That's pretty significant. When bats are eating a lot of insects, there's some significant repercussions to having that many bats dying. So where there has been Whitenose Syndrome in a cave, in most cases, it's not a few bats have it, everybody's dead. There's a few exceptions, but pretty much when it's in a cave, it really is just wiping out that cave. And that can be a real problem for bats who are very specifically going to one cave every year. We have some endangered species that all the bats of that species that we know about are using 6 caves. Well, if one cave, you've lost, if one cave has Whitenose syndrome, you've lost a sixth of those bats, etc. So in some cases, it's extremely scary for some of the species that we know we don't have a lot of. But in general, it's doing it's wreaking havoc on some of even our robust numbers of other species. So it's in 33 states, 7 provinces. And then there are 3 new states, Texas, Wyoming, and Mississippi, where we call it PD because it's too long of a name to say all the time. But PD is the fungus, where the PD has been discovered in a cave, but we have not seen the bats affected yet. Doesn't mean they won't be, but we know it's there in a cave in that state, but we have not confirmed yet that a bat has been infected in that state.
Has that always been there, or it's new to them?
So we're still learning. What they think might have happened, and I might have it on another slide, what they think is happening, because we're also studying other parts of the world now that we're starting to figure it out, everybody's starting to call each other and, do you have this? What's happening here? Is that it's maybe originally from Europe. They have tested caves and it has tested positive. They have some bats who have tested positive for it, but they're not seeing this kind of die out. So the thought was, well, maybe it came through Europe or part of Europe at some point in the past when we weren't studying bats. We didn't know we lost them because nobody knew what we had. And then they've now built up an immunity just like any other disease that kind of runs through, an area. And then at some point, probably a caver, because bats are not traveling across the ocean on their own unless they're on a ship or something, was caving and then went to somewhere in the United States and used the same gear. And it's a fungus, so those spores can stay on your clothes and gear forever, and then they get in the right conditions and they start growing again. So not that anybody knew, but that's most likely what happened.
One question. In any of the known, because you said that, let's just say there's 6 caves that they frequent, can they be fumigated with a fungus? Is there any research?
There's all this research. So now there is U.S. Fish and Wildlife Service is managing this internationally. And there is a Whitenose Syndrome website. Everybody is dumping their resources together. There's now a conference where everybody all over the world that's doing anything related to Whitenose Syndrome comes together. There's federal funding. It got approved pretty quickly when they started realizing this has a potential human impact, when mosquito-driven borne diseases could go, crazy. Agriculture gets extremely damaged when bats are not eating insects. So it didn't take much to convince Congress, for once, that wildlife needed some money. That doesn't always happen, but in this case, pretty quickly. So to answer the question, fumigating is too broad because there's a lot of microclimate things happening in a cave, fungus, etc., that we don't want to kill, but they're trying to figure that out. They're trying to figure out if there's some sort of vaccination they could do. They're trying something topical. There's a ton of research happening, and nobody's quite figured it out yet. Things are working, but then to make them a mass production doesn't work. So what we're noticing is not only is this fungus growing, but see if bats are waking up, I mentioned they have to wake up every little while and fly around, go to the bathroom, etc. They will groom themselves. So then you don't see the fungus because they're just licking it off, right? So you might come into a cave, you might see a bat, and it doesn't look like it has Whitenose syndrome. And at first we thought it didn't. But then when we started seeing all this damage on their wings, more than just normal holes and cuts and things, we started realizing that what ends up happening is that fungus starts to it almost is like roots spreading. It gets on the skin, and because the skin is also cold and it can grow, it's basically sending out little roots sort of to then invade the tissue. And so it damages the wing membranes, which makes it hard to fly. If you've got holes in your wings, you can't fly really well. And it depletes their body fat because it's waking them up. And there's a couple different reasons are starting to figure out why they're waking up. One is they think that it throws off their pH levels. There's something that's thrown off their sodium levels. There's a bunch of different things that are happening, and that's waking them up as if they need to. They'll start to hyperventilate as if they need to wake up and do that. But every time they wake up, they burn calories, right? And so they're thinking in about 30 minutes, I think, they could burn a month's worth of calories. And that's worth it once in a while, but you can't do that but so many times, and then you starve to death because you've just burned through all your calories. So they're flying more, which means they're burning more calories, and they're getting dehydrated because of all this physiological stuff that's getting thrown off. And they're flying when they shouldn't be. So doesn't, just because it's cold doesn't mean you couldn't see a bat fly around, but you don't see a lot of bats fly around. And you don't see them fly around every night, right? Just once in a blue moon. But they're flying more, and they'll also go to the mouth of the cave, which is less regulated, right? It'd be colder because it's exposed to the outside. So then it's cooling them down even more, and they're having to burn more energy to get back to that 40 or 50 degree range. So just kind of weird stuff that shouldn't be happening. So this is the map. That first circle up there in New York, that's the first cave, Schoharie. I never say that right, but somebody might know that name better.
Schoharie, I think.
Schoharie, okay. County is where they first found it, and then it started expanding. And then, oops, that's the latest map. So the different colors show each year, and that's a little misleading because it's not necessarily, with the southern states at least, it's not necessarily that it moved from New York down. It might have. It also might have been, hey, something's going on with our bats, check more of your caves, right? So some of it could be progression of the fungus. Some of it could be they just weren't looking for it, but it was already there. But each winter, they do these surveys. And because the bats are hibernating, they're not picking up bats and messing with them. They're just going into the caves and counting and trying to get some species identification and just general, health of those bats. And they turn that data in. If you are testing for Whitenose Syndrome, you swab the skin of the bat, and you have to send that off. So sometimes you just weren't getting data till, spring or summer. So there's a few reasons why it's not just a simple north to south progression. Does that make sense? Okay. But once we started really figuring out, oh crud, this seems to be everywhere, then from then on, it does sort of seem to be like it is a progression because everybody started surveying, and for a long time, some of these states weren't seeing anything, and then all of a sudden they were. So there's a national response plan, which basically one of the things that they're trying to do is keep people out of caves, because we move those spores as easy as anything else.
You know if that's why they closed the bat caves and bat cave?
Some of it is the species that were in there. If we know there's an endangered species, and I think that was closed before Whitenose Syndrome, bat cave was. They try, and just knowing that there's bats in there using that cave, and if it's a small enough cave, you can really heat up a cave with your body heat. We just decided it was a better location to leave alone, and that's property owner choice. So, if you make your money off of having cave tours, you can't just shut your business down, but So what's happening with commercial caves, Linville Caverns, Bracken Cave, some of those bigger places, is they do a decontamination protocol with the public. So you have mats that you walk across, and there's a disinfectant in the mats, and then you walk through it on your way in, and you walk through it on your way out. And then the likelihood, you shouldn't be touching the walls of the cave anyway, because there's such a sensitive world living on those cave walls. They don't want you scraping things off. So they try to ask you not to mess with the walls anyway, and so you shouldn't have it on your clothes. but you might have it on your feet. So they do that and are able to try to still keep the caves open. Other places have had permission to close caves. If it's federal property and it's not a public cave, it's not too hard to close. Or a state agency or somebody that owns a cave that's not being used, it's not too difficult to just put in a gate over it and keep people out. But there was recently this huge jump, I think it ended up being about 1,300 miles to Washington State. So that was pretty concerning because nobody was expecting to see quite such a significant jump. Because you just kind of hope that you're, like, if you know the path of progression, maybe you can head it off, And then when you see it make that kind of jump, it's just like a little deflating. But there are some states who, right now still don't have it. That's a good sign. There was some thought originally, oh, well, a more southern state, because it's warmer, it's not going to be a problem, right? Because it never gets that cold. But caves, generally speaking, no matter where they are, tend to still be in that 40 to 50 degree range. So even if it's in Florida, the cave, outside might be warmer most of the year than North Carolina, but the cave temperature is still going to be the same. They don't have it in Florida yet, but could be there. Did I do something?
Did it get turned off somehow? Or?
I don't know. It's not going by this either.
That's weird. I wonder if our battery's just cracked.
Oh, actually it's kind of locked up because it's not letting me go back out.
Well, that's...
So I'll keep talking and make up what I think's coming up next while we're waiting, because you got things to do. You don't want to be here all night. So maybe what's coming up is so now that we know that this is what's happening, I mentioned we're trying to protect caves and keep people out of them. We have a whole decontamination protocol that the U.S. Fish and Wildlife Service has established, and that is for any researchers or anyone using a cave. So when our biologists go in, when our biologists go into a cave, they wear Tyvek suits. I think I have some pictures of them, which is basically almost like a paper suit. They duct tape their sleeves. I mean, they try to have no gaps in what they're wearing. And that way when they leave, when they come out of the cave, they have a place where they can decontaminate everything. And that's, your watch, your glasses, your helmet, your lights, boots, etc. And those Tyvek suits then can just be wrapped up and thrown away, and then the clothes underneath have not been exposed to the cave. So it's, it's a real particular process, but ropes, nets, anything you take into a cave has to be decontaminated or thrown away, but you don't want to take it into another cave if you have not decontaminated it. Because we don't want to be part of the problem, We don't want to go in and survey, think we're doing good when we're just spreading spores everywhere. It would defeat the purpose. So, species that are affected by Whitenose Syndrome. Here's the long list. I think it's 11 bats. 1, 2, 3, 4, 5, 6, 7, 8. Yes, 11 bats, including that little tricolored bat that you saw. And there are 3 species of bats that are on the endangered species list. The gray and Indiana bat are endangered, and the northern long-ear, we just recently got listed as threatened because of Whitenose Syndrome. So that was, it's not a good story, but it is a good story, and that we were able to get something pushed through and listed to get some protection pretty quickly, because that process is normally really long. But they were able to kind of push it through because of Whitenose Syndrome. And then this is a positive thing. There are some species of bats that have been swabbed, and the fungus is on their skin, but none of those signs are happening in their body. So it seems to be, and they're in the same cave as another bat who maybe died from it, but there seems to be some sort of natural immunity in some species. And these are some of the species that I mean, we don't necessarily know that, but that seems to be what's happening because there's no reason they shouldn't be impacted by Whitenose syndrome and we shouldn't see them dying, but they're not.
So do they take those specimens in?
Yes, so they have taken some of these species, they're raising them in a lab and they're studying them and taking samples and trying to figure out, is there something in their blood chemistry or their body that then these species that are dying don't have, so we can kind of nail down what the genetics are. Because there almost certainly has to be something genetically. I mean, it's like people, right? When plagues have come through, some people just have a natural immunity and those are the people that survive. And then eventually you kind of work that disease out of the system, right? Out of the community, because everybody who's susceptible to it died. Everybody who's left behind that had an immunity, then, you know, bred and kept that immunity in the system, in the community. So the same thing is happening, we think, with bats.
Since you found it in Europe, how many species of bats are in Europe that we know of?
I don't know.
I was just wondering if they'd gone through that process.
That's what they think. But because they didn't have data prior to it, they don't know if there would have been more species. Yeah.
If they're
Right.
less than
Right.
30 species, then probably.
Right. And I don't know what the number of species is in Europe. But I'm sure it should be somewhere in here in Whitenose syndrome because it would make sense that they would in the Whitenose syndrome research, but I don't know that number. So I mentioned some of this already. They do think that some species are more resistant, and that's going to be great, right? Because those species are going to continue to be able to reproduce, and then you're also reproducing that immunity in new bats. We don't think those tree bats, so the ones who are never using a cave or a mine, because they're not in a climate where that fungus can grow, even if their body temperature is dropping, if they're in a tree, potentially that's not humid enough or cold enough to allow that fungus to grow. So they could get the fungus on them, but then it never seems to be doing anything. So the bats who are not using caves or mines seem to not also be getting Whitenose syndrome. We think that's a climate thing. It could be a species immunity thing, but the Northeast, because they've had it since 2006, we think, or maybe even somewhere before that, we're not seeing that their bat populations are still just plummeting. There seems to be a leveling out. You know, you would think, because it was like plummet, 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 you know, you just eventually wipe out all your bats almost. But there seems to be a leveling out, even of some of the species that are impacted by Whitenose syndrome. So they think that that might also be that immunity thing where even within a species that's impacted by Whitenose syndrome, maybe there's a few that are immune and then they happen to survive even when everybody else around them didn't. They're still trying to figure that out. But that is nice to see because that means, you know, like here in North Carolina, we noticed it around 2010 and we have just every year just seen huge numbers of bats wiped out. And we can at least think, okay, maybe this is not going to be forever, you know, till we lose everything. The other nice thing is we have more money to do bat research because of Whitenose syndrome getting federal funding. The states can apply for that money, and our Whitenose syndrome money helps do our Hibernacula counts in the wintertime and even some of our summer surveys. So we are able to keep on more staff, our typical seasonal staff, where we might just have them for the small survey window season that they would normally come for. We can keep them longer. Maybe we can even get more, and which means we can do more surveys. So it has helped us in general study bats because we didn't have the resources to do that before.
Sorry, is this federal funding relatively really new? Is it something that's been going on in the last 10 years?
It has been, no, probably not 10 years. So 2006, I would say probably the funding started, I can't remember exactly, but probably like 2010 or 11 maybe, I'm guessing. Because once all the states started really all saying, oh crud, yep, it's in our cave, it's in our cave, it's in our cave, then they immediately started going to Congress about it. So it wasn't right away. So I would guess somewhere in there, 8 years maybe.
Findings and research relatively readily available to
Yes.
lay people to?
Yes. So I'll show you the website here in a second. You just have to filter through a scientific journal database because now it's getting to be huge, but anybody can access it. Yep. Oh, so we found gray bats in western North Carolina, which are an endangered bat. We didn't think we had them anymore. And because we got to do more surveys, we got to go to sites we had not been to in a while. And we were doing a survey at a bridge area off the parkway, underneath the parkway, and we found this huge colony of gray bats living in the cracks of the bridge that we never knew was there. So that was like a woohoo, everything is so bad and this is awesome, it was great. And also a ton of Mexican free-tail bats were in there as well. It was like, because as we do a lot of these surveys, we used to be at sites where we would have, 100+ bats by the end of the survey night, and then the next year 4, and then the next year 3, and then 4. And it was just so deflating to go out there and, you're just sitting around not even seeing a bat in the net. So when you hit a place like that, we're all just cutting flips because it's a good feeling to see that somebody's doing well. This is just one example, but there is a lot of research. In this case, the rhodococcus bacteria. This student is in studying agriculture, and he was specifically studying how to keep bananas from ripening too quickly before they get to the grocery store. So they get picked kind of green, but even just in the process of getting them to the store, a lot of them ripen too fast and they lose them. So he was trying to figure out how to put something on the outside of bananas that would slow that oxygenation process down from ripening. And he heard about Whitenose Syndrome, and he heard it was a fungus, and he thought, I wonder if the same thing would work, in however that all the biologies, it seemed to be the same kind of system. So they took some bats, they hibernated them in a cooler with this particular bacteria, it off-gasses, and they had confirmed Whitenose Syndrome on their skin, and then they hibernated them, of course, tagged them so they could find them the next year, radio tracked them, and then they got them back and they tested them again, they didn't have it. So, of course, that's like 3 little bats in a cooler. You can't fumigate the whole cave, but it's one step, and there are multiple examples of that where for some of the research that was going on, somebody realized, there might be a connection, and they're trying it, and it seems to be working, but it's all figuring out how do you make that happen on a larger level.
So the bacteria was taking the fungus.
Yes, it was really cool, and I don't remember all the details about how it off-gasses and kills it, but it was working, so it was killing the fungus. It was pretty cool that it worked. There's also some UV light research, which might make more sense to be able to do in a cave, but then you still have to make it very specific to that one fungus, not all fungus. So, point is, there is some positive stuff happening. Some of the quick last few slides is just to show you some of the commission research. I mentioned the Hibernacula surveys. You can see their Tyvek suits here. Gloves, duct tape, all the gear so that they can decontaminate everything or throw it away. They're not messing with bats. They're just going in and looking and counting. And radio telemetry. I have a couple of slides here. Radio telemetry. Before that, protective bat entrance. You're asking about bat cave and places like that. They can put these steel grates or steel, whatever you call that, protection, but the bats can still fly through those openings and people can't get in, and then they can keep people out. We can put little trackers on bats. And they're really tiny, they're really expensive, so we can't do a lot of it. But if we are trying to figure out where they are going, or if we want to find that particular bat again, then we have some of these, and we can track them. Just like you see collars on elk or collars on bear, mountain lion, pit tags and snakes, all that works the same. It's a way to track them by radio frequency and find the bats again. We found a whole colony of Virginia big-eared bats up near Grandfather Mountain that we never knew existed from radio tracking, because we kept seeing, they kept seeing them, but they couldn't figure out where they were going. But it seemed like we were starting to see more of them, so they were able to get some money to pay for some transmitters and then tracked them back to this private property, this cave on this private property, and there were a really good number of them in there. And then they could do more to protect that particular cave once they know they're there. We also put bat houses on the side of bridges, and then when the bats are coming out of cracks and things in bridges, which are much harder to count, sometimes they will then take up in those bat houses, and then we can get underneath them or take the top off and look down in them and try to see how many bats are in there. Sometimes we are counting in the cracks of bridges or an abandoned building, a barn. We'll go in all those places if we think there are bats in there and try to figure out how many are in there and how they're doing. We also have a new citizen science project. So anybody can be a part of it. And if you have a bat house or know someone who has a bat house, you basically just sit out in the evening with a clicker, and as bats come out, you try to click, you try to count how many bats there are. And if you can, even get a picture of the bats, if you happen to be able to get one, and then you can turn that data into us, and it's just more data. It's great because it's one more roost site that we get the data on. So that's a pretty simple citizen science project. Bats don't take to bat houses as easily as birds do, but when they do, there are usually a ton of them in there. We also have a program called BAMP, and it stands for Bat Acoustic Monitoring. And it was the one I mentioned earlier. You basically put you get all the equipment from us, and you put a microphone on top of your car, and you're given a specific 20-mile route, and you run that 20-mile route at 20 miles an hour so you don't blow off the microphone. And it will collect all the all the bats echolocating around you, and then you turn that back in, they download the data. And then you get maps like this. So the first year we did it was just prior to getting Whitenose Syndrome in North Carolina. So it's kind of perfect timing because we had even if it's just 1 year, we had 1 year of data prior to Whitenose Syndrome. And these are the different routes. So a stopping and a starting point, and then the red line is the road, so your 20-mile route. All over the western mountains. We now are doing this in the coast and I think in the Piedmont. And you would get data back like this, and they'll send you the report so you know that road you went on, here are the bats that got, the sounds that got collected, the echolocation calls. So the tricolored bat, that little one that had the condensation on it, the bigger the circle, the darker the circle, the more bats. So this is 2011, this is 2015. So it's not a great map, but it does show you that you get that kind of data back. Just from driving a route, one person. So that's a lot of data with a little bit of staff time, or a little bit of volunteer time, and that's really helpful.
What is the commitment to something like that? Do you have to be on the road every day?
No, twice a summer.
Twice a summer?
You do it once between May 15th and June 15th, and once between June 15th and July 15th. You go, depending on where you are, there's a collection spot where you go pick up your kit. You start your route 45 minutes after sunset. So usually you have to, at some point you need to run it in the daylight so you know where you're going. But because if you're, driving 20 miles an hour and you're trying to look at a map in the dark and turn left, and some are straight roads, some are not. But you get to your site, a little bit early. You put the suction cup microphone on top. You run the wire in, hook it up to the Anabat equipment, and you record the temperature and a few data collection points, and then you drive your 20 miles, and then you stop and you take the same kind of data collection, the temperature and cloudy and all that, and you take your monitor off and you turn it back in. Super simple. So maybe 2 to 3 hours twice. Yeah.
Are there similar programs here in upstate South Carolina?
I was asking our bat biologist if she knew of that. She thought they had a similar driving program, but she was thinking it was small enough that maybe just their biologists were doing it. She didn't know of a citizen science version of it, but it's worth checking with the Fish and Wildlife Agency in the state to ask, because she wasn't 100. She didn't think they had anything yet, but she wasn't 100% sure. But if you're this close, you know, there could be something in the southern mountains of North Carolina, just, you know, right up the road, where you could be a part of that too. So, so that's one project, and then the roost sites, 2 projects that citizens can get involved with. We also do mist netting. This is a bird net, but it's in the daytime, so it's an easier way to show you the picture. Same kind of netting where you have nets that overlap and there are pockets, and you put them where they're flying. So where birds are flying or where bats are flying, and they fly into it, and it's very, very soft and silky, so they get stuck but they don't get cut up. And then you're right there, so you can go ahead and take them out. And so it's an easy way to capture something that's flying, and then you can weigh them, test their health, take tissue samples, whatever you need to do.
So you touched on another subject. Okay, I know that rabies occurs in 1% of all bat pop. I mean, that's minimal.
Teeny tiny.
People just touch them.
Yes, so we've all been vaccinated.
Yeah.
You have to be. But we also wear gloves. And now we wear gloves because of Whitenose Syndrome. We throw away, unfortunately, gloves every time we handle a bat, just in case. Even though it's summertime when we do these surveys, it doesn't mean the spores couldn't be on them. It doesn't mean they probably haven't shared it with any other bat flying in the area, but there's no reason to make it worse. So, it's the same netting. It's just bat netting is set up a little bit taller, but it was a good picture to show you what that looks like. And then any data that we need to collect, we can collect and then just let the bat fly off. And this is a hoary bat. So I mentioned those tree bats that are heavily furred. So this is one of our tree bats. It's the biggest microbat, and it's the biggest one we have in North Carolina. It's almost the length of your hand, so it's like a big monster of a bat compared to the other bats. Tail membrane and everything is completely furred. It's a beautiful bat. So this is the face, this is an ear, this is like the neck. It almost looks like it has a yellow collar, sort of. This is the belly. Here's a thumb and a wing, and here's another thumb and a wing. Is that starting to make sense? Okay, yep, and there's a foot. Yep. So, and they will eat through that netting quickly, so they're not getting hurt by the netting, but they will do some serious damage if you don't get to them quickly. So, I mean, what typically happens is we are sitting at the base of the net over off to the side, or just like right, you know, a little ways over, and we just keep a check on the net. And you're not letting it go more than a couple of minutes, and then you can get any bats out. So some are real quick and they'll get out right away, but ideally, that's not what happens. When we get them, we can measure. Here's the free tail, by the way. Can you see that? Just to show you. It's so cute. When the Mexican free-tail bats, the first time I'd ever seen them, were in the net, it's like, you know how puppies, like their whole body shakes and their tail's shaking? They were mad. They weren't happy to be in the net, but that's what was happening. Their little tails are going up. It was really cute. Anyway, so if you measure their forearm, it's just consistency, right? So they've learned if your forearm is this particular length, your body is probably this size. So without having to take a bunch of body measurements, you do one measurement, and then over time, if you're comparing that same measurement, you know, you can compare body health that way. So right forearm, they can also carefully pull the wing out and look for holes and scarring for damage. There's naturally going to be some damage, you know, just like we get cuts and scrapes and stuff. But if there's a ton of holes or a ton of scarring, sometimes that's an indicator of poor health or Whitenose Syndrome. So even in the summertime when you're not going to see that fungus growing because it's too warm, or they've licked it off, you can still have an idea, we might need to swap this one because it doesn't look healthy. You can band them, so just like a bird band, it's just those little clips, little C kind of aluminum clamps, and they slide up and down the arm, it's like a earring cuff kind of, and it has a number on it. So if we catch a bat, we know the previous data that we collected on it. Some things that you can do to help, in addition to those citizen science projects, if you're interested, planting a bat garden, that's basically a pollinator garden, right? Because if you're bringing insects to your plants, then you're bringing insects to bats. So planting a pollinator garden is basically a bat garden. But there are, they give you a few additional tips that could be helpful, like, Organization for Bat Conservation and Bat Conservation International. Those are the two kind of expert bat organizations that you can always trust you're going to get reliable information from. Good? Okay. So just quick couple facts on bat houses because people ask about them. I have one here as an example. But you basically want, in a nutshell, I won't read all that, you basically want it to be waterproof so it doesn't get rained in on, but you need some venting because you want them to be able to choose the temperature. If they want to be warmer, they go up higher. If they need some cooler weather, cooler air, they come down to the vent. So just having a vent in there to help them regulate.
Do you supply bat houses?
We don't. We have done a couple of just local projects, like the educator at the coast got some help getting wood purchased, and then she did for I think Bald Head Island community. They've done a bat building workshop kind of thing.
What about if you had volunteers to make bat houses to give to you that you can supply?
That would be great.
She's on it.
I am certain that if we had a way to get the bat houses and we could give them away, like to a school or somebody that already has a pollinator garden.
Because there's probably specific woods like
Nothing treated.
no treated wood, right?
Yeah, and it's pretty, like this was just, I specifically asked my dad, can you build me a bat house with junk? Because I don't want it to be like, like I want to say this was scrap wood and whatever. I think he bought maybe the galvanized screws. He might have even had those. But so the big thing is you need a landing spot. So you can come up here and look. You just need a little wall longer in the back than the front. And it needs some screen on it or some grooves. Because they just need to be able to catch it, right? And then crawl up inside of it.
I'm sorry I keep asking.
No, you're good.
Has the decline in bats possibly corresponded to the decline in honeybees, certain neonicotinoids, and the bugs they're eating?
Right. They have not made that connection specifically. I mean, Whitenose Syndrome really is just, it is what it is. It's wreaking havoc. Certainly some cases of endangered species of bat species is from habitat loss, from loss of food, because we spray everything so there aren't any insects around. But I don't know that there's a specific connection to honeybees, because in most cases they're not eating one type of insect. They eat a variety.
But the honeybees aren't eating one type of flower.
Right.
All this.
I'm certain it has an impact, but I don't think that they have specifically said this bat is impacted by the honeybees. Do you know what I'm saying? I'm sure it's not helped, but so having a vent, having it waterproof, having the landing pad here on the bottom, and then you can come look inside here. Gosh, I cannot think tonight. The chambers, that's the word I'm looking for. The chambers inside have to be really skinny because they want to be packed up in there and be warm. So I think it says 3/4 to an inch is all you want those chambers. It's real skinny. And it can be this big, it can be a single chamber, it can be 8 chambers.
Why don't you want to put them on trees?
Because, isn't that funny? They will roost on trees, but they don't want a bat house on a tree. Because it's too easy for predators like snakes to crawl up and they can't see. And often we stick them in places where there are branches around it and they have to drop to fly. They're not like a bird who can just take off from a branch. So sometimes coming out of bat house on a tree, there's branches around and they would get hung up. So if they get to choose the tree, I guess it's fine. But if we put the bat house on the tree, they don't use it. So it ends up being easier to put them just way out in the open where there's nothing around them. And then they find it easier and they're more comfortable going in and out of it. So big pole, 12, 14 feet up in the air. I just saw, I meant to add it to this PowerPoint. I just went to Kentucky. It was kind of a fluke. I found this little state park and they had bat houses that looked like trees and they just had almost like telephone poles basically. And then at the top they had taken like fabric and built it around a wider piece of wood that they screwed to the top of that pole, like it was hollow, so that around the pole was just like this little inch opening. I don't know if that makes any sense, but anyway, it just sort of from a distance kind of looks like a dead tree. It doesn't look like a PVC pipe pole, you know? So it looks prettier, but it has this whole space around the kind of the telephone pole basically that they could roost in. Side of houses are also great because they often use the side of houses anyway.
Is it better northeast?
In the south, not necessarily. If you go to one of those websites, if you Google bat houses, it'll tell you in this zone you should do this. You know, some places you have to paint them black because it's cold enough and you want to warm it up. But in the south, it's really not really that picky. You don't have to be too picky about it. Certainly if it's facing south, it's going to be warmer. So that's a good thing. But if you couldn't, yes, that's a good thing.
With the side of the chimney that's not being used anymore, being replaced now, because we want.
Yeah. This is a ton of bats inside of a bat house, just to show you how they pack in there.
Do they move right in once you put a bat house up, or do you wait years? Or?
You might wait years. Yeah, it's really, people get really impatient, antsy, yeah. Because, you know, you put up a birdhouse and something will take to it, even if it's not the bluebird you thought you were going to get, you know, somebody will be in there. But bat houses, you kind of just need to watch your area for a while. And if you can be out in the evening and you have bats and you kind of watch where they're flying, if you can stick that right in their face, you know, right in that path, you do have a better chance, but it's not as easy as a birdhouse, so sometimes people give up. Any other questions for me? Yes?
Are squirrels a predator of bats?
No. I took the predator slides out because it was too many slides, but some owls will eat bats. Snakes, you know, if they can get into a spot where bats are roosting, they would eat bats. And, I mean, if a bat is on the ground, you know, certainly pretty much anything would eat it. But some are more, you know, some owls will specifically kind of focus on bats. Snakes are often what's getting into eating bats in trees and that sort of thing. But the biggest issue is habitat loss, because cutting down trees and spraying fields and et cetera is really having a larger impact. Prior to Whitenose Syndrome, that was the biggest impact.
What kinds of trees do they like? I mean, obviously things like the hickories that are shaggy and things like that, but do they roost in sort of dead holes?
Yeah, a lot of times it's dead holes, or if the bark is shaggy, or if it's dead and it's starting to just rot, you know, and come loose and they can get behind it, that's a great space too. If you're going to put out a bat house, 12 feet or so is what they say is a good height. Yeah. And if you Google bat houses, they'll give you plans and everything. You can buy bat houses too from Bat Conservation International and some of those places, and sometimes that's less hassle than having to build one. But if you wanted to build one, they lay out the plans and everything. It'll tell you what wood to buy and how to cut it and how to screw it together, and so they make it real easy for you.
Guys sells them at farmer's market on Saturday.
Oh, nice. That's perfect. Yeah. Anything else for me? We went over. Yes, ma'am.
Do they take volunteers when you're looking for them and?
We used to, but because the decontamination procedures are so picky now, we don't as much.
You're looking at bridges and things, you're
Right.
still covered in everything?
Well, usually in the summertime when we're doing those surveys, you bring spare clothes and you have to Clorox all those clothes. So we have like a station where you shed the outside stuff, and we don't wear Tyvek suits because we die, but yes, same concept. Yes, same concept, yeah. So we don't, so the staff number is a lot, the number of people doing them is smaller because it takes so long to get everybody through. But we do take volunteers for the roost surveys and the bat acoustic monitoring surveys. Yep. Thanks, y'all. Thanks for sticking with me.